Hello, I'm Roman, and welcome back to the series of videos Neural Networks from Scratch in Go, where we using this book called Neural Networks from Scratch in Python, but we writing everything with the Golang. I had to skip one video yesterday. Well, yesterday there was okay, so I'm usually recording one day plus. So today is the Thursday and it will be published on Friday. So yesterday I wasn't able to record the video because I had this small operation and then I get a food poisoning. So it wasn't an easy day for me. And I'm still not feeling that good. I mean, I still have a temperature and, this post kind of procedure feeling. But I will try to move forward. I'm not sure that my brain will be good enough to deal with the neural networks, but I will try. At least, even if I won't make too many progress, the main thing is to be consistent and do stuff every day. Even if I will try to record it for 15 minutes and try, then it's still it's better to build a habit of learning something, even if you don't make any significant progress every day, but you still have this um, habit of approaching the problems. And in the previous time, I started to implement the binary cross-entropy loss code. And there is one particular thing that kind of caught me off guard. And this is these two lines. Because what I thought that this mean calculation from the sample losses on the -1 axis, it will give you one-dimensional array instead of the two. I think there is an example here how it's used. Yeah, so for example, if we have these outputs as a two-dimensional array, so the result will be a vector where each element is the mean value of each row. And I'm kind of confused why they're using the same. Maybe they just, don't want to use a temporary variable. And this is actually will be a two-dimensional and this will be one-dimensional. Because, for example, the wipe red, which is the prediction, should be a two-dimensional array because it got passed into the forward method, and we should have one row dedicated, one row as the predictions for an input sample. Then we kind of getting it clipped, and then we do some calculations on top of this, and then we calculate the mean. And I'm trying to understand how it works for the categorical cross-entropy loss. And what I will do, I will just debug it, and I will try to remember what is happening here. So we have the prediction, and the prediction is 3,000 rows right now with 3 columns. So it's a two-dimensional array. Okay, but then we have the confidences, which is a one-dimensional array, right? So, and then what we're doing is we calculating, we're taking the prediction from the using the target class. We're taking the prediction value for the target class from the predictions, and then we calculating the negative likelihoods. And the main thing is the negative log likelihood there is the one-dimensional array. Okay, so it should be, but again, so it should be that, I mean, the y true is, I mean, this is why I'm kind of getting confused. I'm confused by what the notation they're using here, because if it's one hot, then what's got one hot encoded array, then okay, because it will be two-dimensional, then this will be two-dimensional too. But if it's like one-dimensional array, as it used to be, then I'm not sure how it will work. Will it propagate it? Okay. Let's take a look at the where they're using it. Oh, okay. Reshape labels to be a list of lists. Inner list contains one output, either 0 or 1, per each output neuron, 1 in this case. So they don't actually use it as array of what was array of target classes, but instead reshape. Okay, I need to check it. Okay, I thought that's the. Okay, I think I can comment this. Yeah. Okay, then y equals y equal to 1, the reshape minus 1, 1, I think it was, right? Minus 1, 1. Okay, and then print. But instead, okay, and source. Okay, so it uses from the one-dimensional, it creates two-dimensional with one element inside, right? So this is the two-dimensional, and that's how it looked before. Okay, but how it helps me? How it helps me? I mean, how then it will work? Let's create our layers and use the property reshape. Yeah, but I need, well, of course, in the Python, you can, write this without understanding, but I mean, in my case, next we'll reshape our labels as they are not sparse anymore. They are binary, 0 or 1. What? Reshape labels to be a list of lists. Inner list contains one output, either 0 or 1, per each output neuron, 1 in this case. How? I don't get it. With these new classes, our code changes will be in execution of the actual code instead of modifying classes. First change is to make spiral data object output two classes rather than 3, like so. Next, we'll reshape our labels if they're not sparse anymore, they are binary. Consider the difference here. Initially, the y output from the spiral data function would look something like this, but okay, so the main thing is they use just 2 classes, so it's a binary. Okay. Why we have to do this? Initially, with our softmax classifier, the values from spiral data could be used directly as the target labels, and they contains the correct class label in numerical form, an index of correct class, where each neuron in the output layer is a separate class, where each neuron in the output layer, is a separate class, for example. In this case, however, we're trying to represent some binary outputs where each neuron represents 2 possible classes on its own. For example, we are currently working on, we have a single output neuron, so the output from our neural network should be a tensor containing one value, a target value of either 0 or 1, for example. Okay, the reshape -1 to 1 means to reshape the data into 2 dimension, where the second dimension contains single element and the first dimension contains how many elements. Blah, blah, blah. You're allowed to use money only once in a shape with numpy, letting you have the dimension be variable. Thanks to this ability, we do not always need the same number of samples every time. Not handle the calculation for us. In the case above, where all 0 because spiral data function makes the dataset one class at a time, starting with 0, we'll also need to reshape the y tasting data in the same way. Okay, so it's actually we're going into different thing because before we've been trying to, I mean, I cannot use it to predict several classes, right? It only can be used if we have something like this, 2 classes. Okay, so it means actually that first I need to use a different, I will need to implement a different model, right? I don't need this. This back propagates. Do I need this? I think no. A test backward path. I think no. So we have 2 models. Okay, I don't need how many functions I have now? It's model v2, run model, and that's it. And what I've been thinking, I will need I will need to make a copy of this one because I don't want to get rid of the categorical cross-entropy loss. But I also need run binary model. But I also need to do some changes here, right? No. But I also need to do some changes here because the data and the testing data will be different. Expected, found, made, right? Run binary model. Okay. So before we go next, so first that should be like this. Second, the target classes should be different. Maybe I should convert it to the, well, still not sure. We need to convert it to the dense dropouts. Sigmoid is ready, categorical, okay, and I think this. So this is all I need. Well, first, the target classes should be two-dimensional array, but I'm still thinking how it will work. So we have the y true and we have the clip values. And oh no, we have sample losses. We have y true multiplied by y predicted. I guess it means that we're going to take every value from y predicted clip and multiply it by corresponding value from the row. Okay, well, first it should be like this. Cannot, yeah, you cannot. Right? Okay, let's try to write. I'm not sure because I will need to debug it later, but what I know that the sample losses will be one-dimensional in the end by the size of predictions. Right? Right. Okay, so that should be a two-dimensional. So it will be actually a temporary variable. And I will do what I will do, math, dance. I will make a copy of the prediction clipped just to have the same size. But then what I'm doing, I'm using the apply again, func term 0. But what I'm doing, I have -1 multiplied by target I0 because okay, but maybe I don't need to change it to be a two-dimensional arrays. I mean, in my case, well, maybe here to have Because I'm trying to understand where I'm going to use the fact that it's two-dimensional array. Okay, y tests predictions equals y test. Hey, I think I don't need to do this. The only, I mean, I will leave it as a one-dimensional and I would not change it. Probably I will need to write it in a little bit different thing. And type overalls unit. So minus okay, we have target and then we have logarithm math log from y predicted, so it's actually b in this case. But what do? I multiply them, right? Multiply them. Then plus 1 minus targets. 1 minus targets multiplied by math logarithm from 1 minus b again. But then I need to return mean across every row. So what it means, I need to go over rows. Range row mm, 0 and row rows. Can I take somewhere? Integer, okay. Then I'm taking the data, which is row view. And can I take the row data inside? No. Row matrix date. I remember I've done it somewhere. I've done something similar, probably here, right? Mm. No. Be here. Mm. Max bound. I mean, I have a feeling that I used something like mean value. Do I have mean? Average? No. I don't have. Okay. Okay, what I need to do? I need to take, okay, let's take the data from, where is it? The row view. Then I need to calculate the mean value. Well, I don't believe that Go doesn't have mean value calculation. Really? Mean average. Oh, maybe because it's not in the math, maybe it's in the Go now. Wait. Mean? Yeah, this one. Mean computes the weight mean of dataset. X. Wait, what is X? And if weight is new, mean. Oh, and use it. Okay, let's take a look once again. Mean. Where is it? Go num stat. Mean computes the weight mean of the data set. No, it's not what I need. Okay. I need to calculate the average. So sum equals to 0. For j equals here, j less than data len, right? Sum equals, maybe I can calculate the sum. The returns vector. Okay, but I'm curious. Because 0 j um mismatch 0 and j. No, I want it to be this one, 0 j, and then we need to make the sample losses. Sample losses make what 64 len targets, and then sample losses at this place equals to sum divided by temp, no, data len. And here we return sample losses. Okay, let's write the backward path, and probably I will finish with this for today because it really goes hard, to be honest. What is this? So we need to clip d values. So here it will be this. D values clip. D values clipped. And the values clipped once again. Then making a copy of the values, surprise, surprise, and then we clip them. Maybe I should write a function that does this, but I'll add clip data to prevent division by 0, clip both sides to not drag mean towards any value. Then I need to calculate the gradient. Okay, and here we calculate the samples is just a count. Normalize the inputs we by this is divided by this, then divided by the outputs. Again, outputs is the len. It's a number. Okay, then sample count and outputs count equals to the values dims. Let's extract it in this way. Then we have clipped. Then we need to calculate. Interesting, why not to divide it at the same time? I mean, the values apply and will be func. Count declare but not used. Yes. What we're returning? We're returning the -1 multiplied by true value, which is the target, that we need to convert to float 64. We're taking the target, then we minus clipped d value. Oh, by the way, loss the inputs, and we pass in clipped d values clipped. We pass in the values clipped, then we minus. No. Wait. Multiplied by b, then minus 1 minus float 64 target I. All right, multiplied by 1 minus v, and then this all divided by the output count and divided by sample count. Because I'm not sure why we need to calculate the thing twice, make a division twice. Expected closing. Yes, because this is here. Right, because we do the division twice. We dividing by the number of the outputs, storing it into the inputs, and then we divide it once again. I mean, why do we need to do it once again as we can do it at the same time. Okay, now that we have this new activation function, the loss calculation, we'll make edits to our existing softmax classifier to implement to our existing softmax classifier. So we're going to change the softmax. So we're going to change this one. But it takes, I mean, this one uses the category cross-entropy loss, and this is the activation softmax with category cross-entropy loss. I think we'll make a copy of this and use it in a different way. Okay, the main thing that we'll have two classes. I'm still kind of don't understand how it will work with the three classes, or maybe we just implement in a new model and I kind of didn't understand this shift. Okay, because suddenly we started with a binary. Okay, until now we have used an output binary logistics regression. Now that we learn how to create a trained neural network, let's consider an alternative output layer for. Okay, so we basically implementing a different neural network. Instead of predicting the category, we'll do binary. So 1 or 0. Yes, but it also respect cat versus non-deco, any combination of two classes, and you could have. For example, a model may have two binary output sensors. One of these neurons could be distinguishing between person and non-person, and the other neuron could be deciding between indoors and outdoors. Again, I'm not sure, but it feels like we'll be creating a model that have several binary outputs, different one, right? Binary logistic regression is the regressor type of algorithm which will differ as we'll use a sigma. Okay. I'm still not quite sure how we're going to use it, but okay. I still not sure if I need to make these changes. Well, the first one is yes. I'm not sure that I'm going to use the reshaping, and probably it will influence how I mean, maybe from the mathematical perspective, it makes more sense to have it as two-dimensional array. But I mean, the one thing that I saw is probably this one will differ. I think this is the end of the chapter, right? Oh yeah, we'll actually need to run it. The model performed quite well here. You should have some intuition about tweaking the output layer to try to fit the problem you're attempting to solve while keeping your hidden layers mostly the same. In the next chapter, we're going to work on regression, where our intended output is not a classification at all, but rather a predicted scalar value, like the price of a house. Okay, so we're just creating different types of the output models. And I think this one loss binary cross-entropy loss, same optimizer. This is one loss binary cross-entropy loss. And this one activation softmax category cross-entropy. Okay, so basically solving different problem with this one. I mean, maybe in that case we should have used different data sets because it actually confused me. But okay, so what's we going to do? Loss binary cross-entropy loss. Wait. Oh, So instead of using this complete classifier when we had 2, we'll just use 1. Because previously we had in the calculate thing here, right? Yes, we had a mix of softmax activation and categorical cross-entropy loss. But what will be the activation? Oh, so this is the sigmoid. Okay, now it makes more sense. So here we implement one class because calculation of the backward path was much faster if we combine it. But in general, we will have dense layer, activation layer. We're not using the drop out layer here. Interesting. Dense layer 2, then just the activation sigmoid, and then we're creating the binary cross-entropy loss, and we're creating the optimizer. Okay, this makes more sense for me. I will stop for today, and I will continue tomorrow, so we'll finish with, this part. Most likely I will need to debug it, because I'm not sure that I implemented the binary cross-entropy loss correctly. But we will see. Thank you for watching, and I see you tomorrow. Bye-bye.